Hey guys, welcome back to my channel. Um, Today we are going to continue our notes about logs and exponential functions and kind of look at the graphs again and just kind of summarize what we tried to learn yesterday. I need you to title your notes 9.4C, exponential and log functions summary. In class on Friday, we're going to dig into what's called log properties, which is going to help us understand like how to work with logs a little bit more, help us build towards solving equations with logs. Okay, so the first thing that we need to do is we need to learn about or review inverting a function. And so we are going to set up this function and say, okay, to invert it, we are going to switch. To invert it, we are going to switch our x and y. We're going to write x equals 1/2 to the y minus 5 plus 4. And then we need to solve for y. So we're going to subtract 4, and we'll get x minus 4 equals 1/2 to the y minus 5. Now I'm going to identify that I have one of those exponential equations where I can kind of do the color coding and remember our formula. So if I have b to the y equals x, I can turn that into log base b of x equals y. And so this one currently I have a b to the y equals x. And so that is going to be this and this and this. So we're going to rewrite like log base 1/2 of x minus 4 equals y minus 5. And so then we're going to add 5 to both sides to get y by itself. I just want to make sure that we are identifying that the plus 5 goes on the outside of these parentheses. So our answer is going to be y equals log base 1/2 of x minus 4, but then outside of that, we're going to write plus 5. That is what uh, K inverse is called. So K inverse of x is equal to log base 1/2 of x minus 4 plus 5. Okay, in terms of domain and range, this function's domain is all real numbers, and the range is y is greater than 4. You can take a look at the graph, but also we know that this thing is going to open up. It's going to go upwards. And so the bottom value we could get out is just a little tiny bit above this 4. And that's why the range is y is greater than 4. So then what that means is our domain of this function is x is greater than 4. And our range is all real numbers. So this is just going to kind of prove that point. We're going to take a look at the graphs. We're going to identify that those things are true. So here we go. What I'm going to do is I'm going to make a table of x values where I can do k of x as the outputs. So if I put in, like 0, no, I'm going to do like 3 and 4 and 5 and 6 and 7 and see what I get out for each of those. I'm going to use my calculator to do this. So I'm going to type this thing into y equals, and then I'm going to go to the table second graph and see those values. Okay, so I get 3, 8, I get 4, 6, I get 5, 5, I get 6, 4.5, and I get 7, 4.25. So then I'll sketch these points 3, 8, 4, 6, 5, 5, 6, 4.5, 7, 4.25. And then we sketch our graph like this. Okay, so there's our graph. Next, what we need to do is we need to talk about our inverse. And so what we're going to do is we're going to flip all these values. So now the x values are the outputs and the y values are the inputs. The inverse of x. Okay. So I'm going to have the 0.83. I'm going to have the 0.64. I'm going to have the 0.55. I'm going to have the 0.4.5. 6, and I'm gonna have the 0.4.257. Because what I can do is I can take this column and turn it into this column. Inputs become outputs, and outputs become inputs. Okay, so we are going to plot those points: 8, 3, 6, 4, 5, 5, 4.5, 5, 4.25, 7, that. And so that graph is going to look like this. Okay, and so then we are kind of seeing the proof that we have the correct domain and range. I'm just going to kind of remind ourselves about the horizontal asymptote that the blue graph has. And then if I have a horizontal asymptote that's being reflected across the line y equals x, then that horizontal asymptote becomes a vertical asymptote. And so this red graph has a vertical asymptote at y equals x equals 4. Okay, domain is all real numbers. Range is y is greater than 4. Our domain of the inverse is x is greater than 4, and our range is all real numbers. And so hopefully seeing the graphs and identifying this relationship makes sense now because we can see that there's a visual relationship between those two functions. Okay, the next problem that we're going to do is we're going to do one that's already a log, and we're going to turn it into an exponential function by taking the inverse. And so when we invert, we are going to switch the x's and y's and solve for y. The one thing that I want to remind you of is that ln is log base e. And so of whatever this stuff is, y minus 2. Okay. And so, yes, it is log base e, but I'm just going to write it as ln because I want to remember that it is ln. It is log base e, but that's not how we write it. We just write what's in blue. So what I have to do to get rid of the stuff around the y is I have to subtract 5 from both sides. So I get x minus 5 equals ln y minus 2. And then I have to think, okay, well, now I have this like implied base, which I'm talking about here. And then I've got the exponent, and then I've got the stuff on the inside. So what I have is log base b of x equals y. Nope, I'm sorry, we did it a different way. Log base b of y equals x, and we are going to rewrite it as b to the x equals y. Okay, and so what I'm going to rewrite is e to the x minus 5 equals y minus 2. And then I have to add 2 to both sides to get y by itself. And so I get y equals e to the x minus 5 plus 2, which is going to be what h inverse of x is called. So h inverse of x is equal to e to the x plus 5 plus 2. Sorry, minus 5. X minus 5 plus 2. There we go. So let's talk about it, domain and range at this point. I know that the domain of this function is x is in an element of the real numbers, all real numbers. The range, it starts at 2 and goes up from there. So it's y is greater than 2, which means that I should be able to kind of pull back to the original function and say the domain of this function is x is greater than 2, and the range is y is an element of the real numbers. Okay, so this is a big summary slide. There's like, a ton of information on this screen. I'm going to talk about each of these things real quick, but I want you to make sure that you have all of these pieces of information written down. So if I take less time to explain than you have to write, I want you to pause the video and actually write down all these notes. I'm just going to kind of look at this first half. which is the exponential function stuff first, okay? The parent function is just y equals b to the x. The a is a vertical scale factor, and so if a is bigger than 1, then we have a stretch, and if a is between 0 and 1, we have a compression, and that affects our y-intercept, and so we have to be aware of that. Okay. And then we know that we have these H and K translations that work the same way as they always work. We also have talked about a lot of times so far this unit that the domain of every exponential function is all real numbers. And then we just have to pay attention to our range because our range could be y is greater than k, which is usually what it is, or y is less than k, just if a is a negative number. So if a is negative, then that means that the whole thing has been reflected across the x-axis, which is what happens every time a is negative. And if that happens, then we have to deal with a y being less than k. For these log functions over here, our parent function is written here. It's log base b of x. You'll notice that like basically any log or parent or exponential function has a b in it, which is the base, and any function has a different base. Like the b determines the base. So again, we got a vertical scale factor. This time our x-intercept is always 1, 0, unless we have translations. And it's kind of like this too, where like if I have a y-intercept of 0a, but then I shift it right and up, that's gonna change the y-intercept. Just like if I have a x-intercept of 0, 1, 0 over here, it's gonna change the x-intercept if I translate it left, right, up or down. Which is why we have to talk about these h's and k's. So just be aware of that. The domain is going to be x is greater than h, and that kind of makes sense because it's like the inverse of um, the range, and so it's the inverse of this function, and so if it's the inverse of that function, then this kind of goes like this, and you'll kind of notice that maybe the k here actually kind of becomes the h here, so that's kind of interesting. It's not exactly that clean, but it's kind of like that. And then the range is all real numbers for every log function. One more example, then I'm going to tell you what you need to do for the rest of the hour, and then you'll be free to work on your assignment. So this one is actually really similar to the first one we did. It's just there's a little more to it. So we know that the domain of every exponential function is x is an element of the real numbers. And we know that our range is really dependent on what the graph looks like. So you can take a look at your graph and you're going to see that it's going to look something like this. Now, I know that I told you, hey, be really careful about how you graph, but I'm just going to kind of try to get a picture at least so you can confirm that you did it correctly in your calculator. I don't know exactly what it looks like, but I know it's going to look something like this. Okay. Um, if I'm asking you to really graph, then I want you to put the points on the graph and really check. Okay. So, um, our range is going to be y is greater than -5. So now we need to find f inverse of x. We're going to set in x equal to 3 times 1/2 to the y minus 1 minus 5. That is the process of inverting. Then we need to solve for y. So we're going to add 5. I get x plus 5 equals 3 to the times 1/2 to the y minus 1. I'm going to divide both sides by 3. I'm going to get x plus 5 over 3 equals 1/2 to the y minus 1. And now I have exponential form where I can rewrite it as a log. So I'm going to show that. Okay. Log base 1/2 of x plus 5 over 3 equals y minus 1. And then we add 1 to both sides. Again, that goes on the outside. So we're going to say y equals log base 1/2 of x plus 5 over 3 equals, oh, sorry, and then plus 1 at the end. Okay, that is f inverse. So we're going to label it as such. F inverse of x equals log base 1/2 of x plus 5 over 3 plus 1. And then we can take this domain and make it this range. So it's going to be y is an element of the real numbers. And then the domain becomes the range becomes the domain. So then this is going to be x is greater than -5. Okay, that is it. I'm gonna zoom out so you can see my whole problem there. Okay, there's two things you need to do tonight, now during this class. I expect that you are working during class. It's not okay to just go wander. You all tend to go wander sometimes. You have a 9.4b homework. I know that today is 9.4c. We just didn't hand out the homework yesterday, so you got to work on that. Then, with 25 minutes left in class, everyone needs to work on the exponentials and logs exit ticket. It's a half sheet. There's two problems on the front, two problems on the back. It's my expectation everybody works on it individually and turns it in at the end of the hour. I need to see where you're at with this, because I want to know what I need to reteach and what I need to assume you can do. So, when we get to, for you all, it's going to be 220. The sub is going to pass out this worksheet. You are going to complete it and you're going to turn it in. Everybody needs to be in the room for this thing. Okay. Everybody needs to be here to take that. It's not okay to just go wander. All right. That's it. If you finish your 9.4b homework, you can be done and not have homework until Friday. If you don't finish it, then it is my expectation that you finish it for homework. All right. See you all on Friday.